Okay, so the problem is we don't always have common denominators. So when we need to get common denominators, we want to find what's called the least common denominator. So let's pretend like we have a fraction like 3 over 10 plus 1 over 12. So we can't add those fractions because the denominators aren't the same. So what we do is we want to think of it in terms of factors. 10 is 2 times 5, right? And 12 is 2 times 2 times 3. So we want to get those to match up. So you take the greatest number of times a factor appears. Like my LCD, that's least common denominator, is going to have 2 2's. I don't need another 2 because I already got 2. That's enough. And then I'm going to need a 3, and I'm going to need a 5. And so if I multiply that together, it's 60. So 60 is the LCD. Now, one nice thing about doing it this way, I shouldn't have crossed out my 2. Let me put it back, is you compare. What do I need in the LCD, and what do I already have? So I already have a 2, and I already have a 5. So I need another 2, and I need a 3. So I need a 2 and a 3. And this is one way you could look at it. You might just say, oh, it was a 10, I need to multiply by 6. Yeah, 2 times 3. Okay, so then that gives me a new fraction here. 2 times, let's see, that's going to be 18 over 60, right? Okay, so that's that one. And now we're going to do the same thing over here with the 12. I've got a 2, a 2, and a 3. I've got the 2, the 2, the 3. I need a 5. So I'll be multiplying by 5 here and here. And that's going to make this plus 5 over 60. So I found 60, the least common denominator. I got both fractions to have a 60. Don't reduce them because we call this building the fractions. So that's good. Now we can add the numerators. So what's 18 plus 5? 23. Now sometimes this will simplify, sometimes it won't. This time it doesn't, so we're done. Okay? That's the idea. So that's how you do it with fractions. Now we're going to look at finding the LCD for these polynomials, or rational expressions. Okay, so look at the denominators and factor. Well, that doesn't factor. It's just 2x minus 3. This doesn't factor, so it's just going to be x plus 3. So the LCD, I'm going to need this factor, 2x minus 3, and I'm going to need this factor, x plus 3. Now, you might have a question, do you want me to multiply that out? I'm not going to because I'm going to be using factors to get common denominators and things like that. So I would not multiply it out just now. Maybe later I would want to, but I would just leave it that way for now. All right, let's look at another one. This one has some factoring. So I want to factor the numerator. It's got a GCF of 5x. And make sure that's correct. 5x squared, 15x. Okay, that's good. And now I need to factor this denominator. That factors into x plus 3 times x plus 3. So what will I need in my LCD? Well, I'm going to have 2 factors of x plus 3. So you have to take, if it repeats, you have to take the one with the bigger number. So that one has 2 factors of x plus 3, so I need both of those. Oh, and I need a 5x. And I would like my 5x in the front. And I didn't really leave enough room to write it in the front, so I'm going to put that 5x in there. And there's my LCD. So I have to have the 5x. I don't need 3x plus 3's. I just need these 2 right here, and then I already have this one accounted for. So that's the approach. And then I think we're going to do these problems, but you don't want it to be any bigger than it has to be because these get very large when we're trying to multiply these binomials out. So.